Hi everyone, this is Mrs. Watson. I'm doing the Chapter 8 review. The first question says to draw an example of a regular convex polygon. So first off, remember regular means all sides and angles are equal. Convex and concave are new, and convex means it just has smooth edges, where concave goes in, kind of like a cave goes into the earth. So here's one I can think of that's regular and convex. See, all sides and angles are equal, and it doesn't curve in. Here's a non-regular figure that's concave because it dips in. Okay? The next question that we have is I can describe how the measures of interior angles and exterior angles are related to the number of sides in a regular polygon. So first off, a regular polygon has an interior angle of 170 degrees. How many sides does it have? Notice the word right here is interior. So what that means, it's an inside angle. So we have a couple different formulas. We're going to use this one. I equals n minus 2 times 180 over n. So sometimes we know what n is, and n is the number of sides. Others we know what I is, which is the interior angle measure. Today we know I, so we're going to do 170. And we're going to do n minus 2 times 180 over n over 1. And then we're going to cross multiply. What we end up with is 170n equals n minus 2 times 180. We're going to then distribute, and we're going to get 170n equals 180n minus 360. We're going to subtract 180n from both sides. And that's not a subtraction sign there. Sorry about that. We get negative 10n equals negative 360. We divide both sides by negative 10. And we get n is equal to 36. That means it has 36 sides. Okay? Now the next one asks, what's the exterior angle? Exterior angle is 360 over n equals e. We know how many sides, it's 36. So we're going to go 360 divided by 36. And that is going to equal 10. So that's the exterior angle measure. These formulas right here that I'm starring are really important that you have in your notes. Okay? Now it asks to find the measure of each interior angle of a regular nonagon. Remember that a nonagon has 9 angles. We already know how to find the measure of an interior angle. We're going to do I equals n minus 2 times 180 over n. And in this situation, n is 9. So we end up with I equals parenthesis 9 minus 2 times 180 divided by 9. And I will equal, what we end up then with is 140 degrees. Now, unfortunately, the next problem is not showing up. I did not save this as a PDF. So you can definitely ask me for help on this one. What I can tell you, though, is that to solve for x, notice the word up here says sum. So first off, if you notice all the variables are in the angles place. We have this formula, s equals n minus 2 times 180. In the first situation, n is 4. We can then get a value of a sum is equal to 360, and then we can add all those variables up and set up an equation. And the same with the next one, we can do the same idea. Let me know, though, if you have more questions on that one, since, unfortunately, it did not come over. I apologize. The next question asks you to find the sum of interior angles of an octagon. So in this situation, and I'm not going to actually solve it for you, but remember sum is equal to n minus 2 times 180. So on the first one, octagon, n is equal to 8. And so we're going to do 8 minus 2 times 180. In the second one, n is equal to 14. Okay, a little bit of a technical difficulty there. I don't know if this is going to show up all the way, but what I had here was that the sum is equal to n minus 2 times 180, and n is the number of sides. In an octagon, n is equal to 8. Okay, so we're going to do 8 minus 2 times 180. In the next one, n is equal to 14. So we're going to do 14 minus 2 times 180. And the last one is n is equal to 55. And so what we're going to do is 55 minus 2 times 180. Okay, hopefully that makes sense. Just plug those in your calculator and you'll get an answer. The next problem we have is talking about how similar figures are related. If two quadrilaterals are similar, remember that we have some ratios. This one says the smaller has a side length of 20 and an area of 30 centimeters. The side length of the larger is 30. Then what will be the area of the larger quadrilateral? So in this situation, we have we use L for length, for side length, because there's a lot of letters. So we have big L over small l equals R. And we also know that big A for area over small area is equal to R squared. So in this situation, and I'm sorry that square doesn't look quite right. It's about time for me to get a new stylus, which I will be getting here. So in this situation, our big length, notice up here it says the length of the larger quadrilateral is 30. And then it says the smaller has a side length of 20. So that means R, that's what R is going to be, and we're going to get 1.5. The next problem, the next side of the ratio says the big area, remember that's what we're trying to find. So we have x over the small area is 30 equals 1.5 squared. See how this is R and this is R squared. So I'm going to do the work down here, and we get x over 30. Okay, well what we have is x over 30 equals 2.25. We're going to then cross multiply, and x is going to equal 30 times 2.25. Okay? The next problem is very, very similar to this. So in the next problem, it says that two quadrilaterals are similar. The larger has a perimeter of 50 and an area of 900. If the perimeter of the smaller is 20, then what will be the area of the smaller? So perimeter is the same. Big P over small p is equal to R, and we know that big A over small a is equal to R squared. So in this situation, we have 50, which is the big perimeter, over 20 is equal to R, and that's 2.5. And then we also have the big A is 50, the small one, or excuse me, the big A is 900. Over x is equal to 2.5 squared. Okay, what we're then going to do, and you're going to have to figure this out, you're going to cross multiply, and what you end up with is 900 equals 2.5 squared times x, and you're going to divide by 2.5 squared, and that's what x is. Okay, unfortunately my calculator is also not working, but I want to make sure this is finished, so you can just put that in your calculator. For number 8, you really just need to see me. This is a challenging problem, but see me, and I can try to help you out with it. Okay? Next that we're going to do is just find the area and circumference of a circle with radius of 10. Remember, area is equal to pi times r squared. And so what we're going to get is pi times 10 squared, and we get 100 pi. A lot of kids always usually multiply by pi, so that you can also get 314.15 centimeters squared. Okay, either option is fine. The next one we have is circumference, which is 2 times pi times r, and so we're going to get 2 times 10 times pi, and we're going to get 20 pi, or you can multiply 20 times pi and get an answer. Remember, diameter is the whole circle. So in order for you to find the area, you need radius. So you divide that by 2, and you're going to get 7.5. And so our area, again, will be 7.5 squared times pi. You can write that in your calculator, or you can keep it just like that. Circumference can also equal pi times 2, or pi times d. So what we can literally do is write 15 pi, okay? Okay, the next one asks you a little bit more of a question. It says if the area of a circle is 121 pi inches squared, what is its radius? So what we know about an area, we know area is equal to pi r squared. So this situation, we want to find the radius. We have the area. So we're going to do 121 pi equals pi times r squared. Pi's cancel out. We get 121 equals r squared. To get rid of a square, we take the square root. R is 11. In the next situation, it says if the circumference of a circle is 20 pi, what is the area? Okay, well, you know this about circumference. You know that circumference is equal to 2 times pi times r, and you know area is equal 2 pi times r squared. So they gave us that 20 pi equals 2 times pi times r. We can solve this and we can get what our radius is. We're going to divide by 2, and r is 10. And then we can substitute over here, pi times r squared, and we get 10 squared times pi. And we get 100 pi, or you can multiply through. Okay? Then it says find the area of each shaded region. Again, this did not save through, so please see Watson. Okay? I'll be able to help you with these two as well and give you some guidance. What I can let you know about these two problems right here is that, remember we talked about find the area of the whole minus area of the part. Okay? Make sure that you look at that right there. Okay? The rest is just bonus, and I'm not going to go through how to do those. Please, please, please come see me. You know I'm available every day at lunch. I'm available any day after school. But the last day you can take this test is Wednesday. Okay, so I hope you enjoyed this. I can't wait for you to take the test and do amazing. I'll talk with you soon.